Let's work on some pre-calculus today. Graphing functions. Okay, we'll just go over a quick example here. So in your graphing functions, a lot of times, at the beginning of pre-calculus, you're going to have the use of a parent function. So let's say we have f of x equals 5. So our domain is going to be a negative infinity less than x, less than infinity, which is negative infinity, infinity, only if we define range as a set of values of the dependent variable for which a function is defined. Therefore, the domain is a set of input or argument values of which the function is real and defined. And it will be even if f of negative x equals f of x. So therefore, x includes all real numbers. It will be odd if f of a negative x equals a negative f of x, and it still includes all real numbers. So then we go back to our example here. F of x equals 5. So we would draw our graph. This being x, this being our y-axis here. Okay. So then we have 0, 1, 2, 3, 4, 5. We can label that, and our line being here, because we know that f of x equals 5, and so therefore f of x is y equals 5, and if y is 5, we don't see an x here, so our interval is going to be 0 and 5. Okay. So for this graph, we're using the parent function, and 5 is the constant. Here are the pre-calculus parent functions. So the first one, we have f of x equals a, which is a constant function. We'll have our x, y-axis, and it's going to be a straight line. Okay, it's a linear function if f of x equals x, where the line goes straight through the origin and continues on. Then we have our absolute value function. On the absolute value function, we're going to have our x, absolute value marks there, and then it doesn't make a perfect parabola, but the lines go straight in either direction. So in the greatest integer function, you're going to have f of x equals x, whereas you see the notation marks here with the open intervals. Then you have your widely used quadratic function, as you remember from algebra, etc. F of x equals your x squared, and you're going to have your parabola open up upwards. You have your cubic function, okay, there's your cube there, 5x. So f of x equals x cubed, and at this point you have your graph does coincide through the origin, but it's kind of half of a parabola up, half of a parabola down. Then we have our f of x square root function. So you have your radical, and then you have your x-axis, y-axis, and it has half of a parabola opening up to your right. So you have your cube root function. So you're going to have your 3 root x, x-axis, y-axis. So you have half of a parabola opening up positively to the right, half of a parabola opening up negatively to the left. So you have your exponential function, f of x equals a to the power of x. At this point, you're going to have a positive slope, which slopes progressively upward to the right. Logarithmic function is going to be f of x log sub ax, which is going to be half of a parabola with the y-intercept. It's going to be negative. Then you have your f of x, which is 1 over x. So when it's fraction here and x is in the denominator, you're going to have 2 different lines there. Alright, finally we have our rational function. F of x equals x squared plus 1, x minus 2 over x plus 1 multiplied by x minus 2. Okay, rational function, you can draw your lines here. You're going to have 2 lines. Very simple. And it's also similar to the 1 over x. Okay, they look kind of the same, but it's moving here to the y-axis. Then you have your old trigonometric function, which you already know. F of x equals sine x. Okay, goes to the origin. F of x equals cosine x. Okay, you have a positive y-intercept. Alright, f of x equals tan x. Okay, you have half parabola up, half parabola down at progressive intervals along the x-axis. If you memorize these, you'll be okay. Thank you.